Hi, it's Jason here with Help Me with SAT. Today what we're going to do is go through the first 9 problems in section 4, which is calculator section of the practice test number 5. So we want to go through the first 9 problems. Now remember, these are usually considered the more easy problems, the more straightforward problems, but they're worth the same as the hardest problem on the test. Each problem's worth the same. So it's important to get these right too. Okay? All right, let's start here. Let's take a look at number 1. Number 1 says, according to the line graph above, between which 2 consecutive years is the greatest change in the number of 3D movies released? All right, so what we're looking for here is the greatest change, or when it goes up the most. So this one, we can look specifically at the numbers, but we can see the change here is the greatest, and that's between 2010 and 2011, so it's letter D. Okay? Next one says, some values of the linear function f are shown in the table above. Which of the following defines f? So to figure this one out, all we really have to do is plug in the x's and see when we get those y's. Okay, so if we plug in 1 for letter A, we're going to get a 5. We plug in a 3, 2 times 3 is 6, plus 3 is 9, so that's not correct. Okay, next one, if we plug in a 1, 1 times 3 is 3, plus 2 is 5. All right, and we get a 5. So that one's good there, but if we plug in a 3, we get 3 times 3 is 9, plus 2 is 11, so that one doesn't work. Okay, next one, we plug in a 1, 1 times 4 is 4, plus 1 is 5, so that works. We plug in a 3, 3 times 4 is 12, plus 1 is 13, that works. We plug in a 5, 5 times 4 is 20, plus 1 is 21. So the correct answer there is C. That's just a plug it in and go. Okay? The next one says, to make a bakery signature chocolate muffins, a baker needs 2.5 ounces of chocolate for each muffin. How many pounds of chocolate are needed to make 48 signature chocolate muffins? Okay, so in this one, what we need to realize is that it says 2.5 ounces of chocolate are needed for each muffin. How many pounds of chocolate are needed to make 48 signature muffins? So first what we need to do is 48 times 2.5. All right, that's going to give us 120 ounces total, because we have 48 muffins and 2.5 per each. Then we have to figure out what 120 ounces is as pounds. Well, there's 16 pounds in an ounce, so we need to divide by 16, and that gives us 7.5. So 7.5 is the correct answer there. Okay? All right, let's take a look at the next one. The next one says, if 3 times c plus d equals 5, what is the value of c plus d? Okay, so 3 times c plus d equals 5, and we're looking just for c plus d. So in this case, we want to solve for c plus d. So what do? Okay, we divide each side by 3. That gives us c plus d equals 5 over 3. Usually you're used to solving for a single variable, but here you want to solve for c plus d because that's what they're looking for. That's what the SAT does. So the correct answer there is 5 over 3. Okay? Next one says, the weight of an object on Venus is approximately 9/10 of its weight on Earth. The weight of an object on Jupiter is approximately 23 over 10 of its weight on Earth. If an object weighs 100 pounds on Earth, approximately how many more pounds does it weigh on Jupiter than it weighs on Venus? Okay, so for this case, what I think we can do is if we just take we pick, well, they've picked 100 pounds, okay? It weighs 100 pounds on Earth, right? Yeah, 100 pounds on Earth. How many more pounds does it weigh on Jupiter than it weighs on Venus? Okay, so if it weighs 100 pounds on Earth, on Venus, it weighs 9/10 of its weight on Earth. So we multiply by 9/10, and that gives us 90 pounds. Okay? If it's 100 on Earth, on Jupiter, it weighs 23/10. So we multiply by 23/10. All right, and that gives us 230. Now here's the key. It wants to know approximately how many pounds does it weigh, how many pounds more does it weigh on Jupiter than it weighs on Venus. So we have to subtract. 230 minus 90 equals 140. 140 is the correct answer. Okay? Next one. An online bookstore sells novels and magazines. Each novel sells for $4 and each magazine sells for $1. Sadie purchased a total of 11 novels and magazines that have combined for a price of $20. How many magazines did she purchase? Okay, here's one where we have to use two different equations. Okay, if we say the novel is N and the magazine is M, okay, we can set up our first equation, $4 for a novel, so 4 times N, all right, plus $1 for a magazine, 1 times M, okay, equals $20. Okay, so whatever she, however many novels she spent, it's going to be $4 a novel. How many magazines she spent, it's going to be $1 a magazine, and that equals 20. But now we know something else. Okay, she purchased a total of 11 novels and magazines. So novels plus magazines equals 11. So before even knowing how to do this one, you just want to write down what the problem is telling you. Okay? Now in this case, we have two equations. So when you have two equations, okay, you can add or subtract them to help solve them. In this case, all right, we're going to want to subtract them because we have 1m here. There's no 1 there, but that's the same as a 1m down there. So if we subtract them, the m's are going to go away. And then you're only left with one variable. Much easier to solve. So 4n minus n is 3n. 1m minus 1m is 0. So we don't have to write that down. Okay, 20 minus 11 is 9. Okay, now we solve for this, divide by 3, and n equals 3. Now we have to go back and say, what does it want us to tell? Okay, how many novels did she purchase? Okay, well that's what we solved for, n. Okay, so the correct answer here is 3. Very good. All right, 3 more to go here. The Downtown Business Association, DBA, in a certain city plans to increase its membership by a total of N businesses per year. There were B businesses in the DBA at the beginning of this year. Which function best models the total number of businesses Y the DBA plans to have as members X years from now? Okay, this is definitely a reading question. All right, there's not a whole lot of math in here, but it's reading. For these, I sometimes suggest you read the question twice because by the end, you're probably a little bit lost. So let's look at it again. The DBA in a certain city plans to increase its membership by a total of N businesses per year. There were B businesses in the DBA at the beginning of this year. Okay, which of the function best models the total number of businesses Y the DBA plans to have X years from now? Okay, so there's B businesses, that's a constant. Okay, so we're going to have B in our equation. It wants to increase its membership by a total of N businesses per year. Okay, so each year it wants to have increase its membership by a certain amount, okay, by N. Now, it says here years are X. So you're going to multiply that N by X, okay? So it starts with B, and then every year, which is the X, it's going to increase by N businesses. And that's going to tell you how many members it has. So in this case, it's Y equals NX plus B. Okay, with the reading ones, read them twice. because by the time you're finished reading it the first time, you're probably a little lost. Go back and read it again, okay? This is a reading and definition question. As you can see, there's very little math, very little computations to do. Now, this one's almost the exact opposite. Number 8 says, which of the following is equivalent form of 1.5x minus 2.4 all squared minus 5.2x squared minus 6.4, okay? For this one, all right, yes, you can combine them all, all right, but you can narrow it down, I think, to C and D because they have an x term, okay? They have a middle x term here, which is going to happen when you square these, okay? When you square them. Then basically, it's just a matter of working this out. And you can use a calculator for this one, okay? So when you do, you get, if you multiply it, if we FOIL it out, okay? Because we can think of this as 1.5x minus 2.4 times 1.5x minus 2.4, okay? And then we do the FOIL method, okay? First, outside, inside, and last to figure that out. When we do that, we get 2.25x squared minus 3.6x minus 3.6x plus 5.76. Okay, that's the first one. That's this one here. Then we can do the same thing, all right, and multiply the next one out and figure out what we have or what we will get. Okay. So, well, the next one is not squared, so you don't have to multiply that out. Sorry about that. My eyes are going bad here. So then we just have minus 5.2x squared minus 6.4. Right? Now it just becomes a matter of combining the like terms. And when you do that, okay, you get negative 2.95x squared minus 7.2x plus 12.16, okay? And that gives us letter C. So this is a matter of just plugging it in, figuring out which one works best, okay? Almost the opposite of number 7. All right, number 9, last one we're gonna do here in this section. In the 1908 Olympic Games, the Olympic marathon was lengthened from 40 kilometers to approximately 42 kilometers. Of the following, which is the closest to the increase in the distance of the Olympic marathon in miles? Okay, in miles. So what we get here is very important. 1 mile is approximately 1.6 kilometers, okay? So we're increasing it by 2 kilometers. We went from 40 to 42, okay? And so it's increased by 2 kilometers, okay? Now, we know 1 mile is approximately 1.6 kilometers, but we have to go in the other direction. We have to go from kilometers to miles. So what you can do is say, all right, 1 mile equals 1.6 kilometers, okay? So if we're trying to figure out how many kilometers, or to go from kilometers to miles, what you need to do is divide. And when you divide this, you get 0.625, okay? That says is for every 1 mile is 6.25 kilometers. So then you multiply this by 0.625, and you get 1.25, which is that one, okay? So it gives us miles to kilometers, we have to switch it around from kilometers to miles. So we can divide the two, and that gives us our conversion. All right, I hope this was helpful. And take a look back over these if you need to. And remember, the first 9 questions worth just as much as the last 9 questions. So it's important to focus on them as well. Have a great day, everybody.